Okay, hi guys. So I'm going to do this problem. The height of a tree at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Now guys, what we want to be in the habit of is if they tell you something is differentiable or twice differentiable, we have to know what that means. So we have to know that if they're telling you something is twice differentiable, or even if they just told you it was differentiable, they're telling you two things. They're telling you that it is continuous, and they're telling you that it is differentiable or smooth. All right, so they're telling you it's smooth and continuous, and the smoothness implies the differentiability because there's no sharp corners. Okay, and the reason it's important to notice that is because if we do have to come up with an explanation, it's very likely to involve, our explanation is very likely to start off with because h is continuous and differentiable or something like that, you know. All right, so we're going to use the data in the table to estimate h prime of 6, and then using correct units, interpret the meaning of h prime of 6 in the context of the problem. Okay, so, all right, so 6. So you're looking for 6 years, and it's not in the table, okay, but it's between years 5 and 7. So remember the derivative, another way of thinking of it is the instantaneous rate of change. You can't find the instantaneous rate of change, the rate of change at a very single moment from a table. But what you can do is you can find average rates of change and use those to estimate. So if I just do the average rate of change from 5 to 7, because 6 is between there, I'll get an estimate. Okay, so this is part A. So let me find the average rate of change from 5 to 7. So h of 7 minus h of 5 all over 7 minus 5. This is 11 minus 6 over 2. That's 5 over 2, and we need, okay, so I'll say h prime of 6 is approximately, don't use equals here, guys. And then we need units, meters per year. And I think they'd be fine if you just did this and then said meters per year, because you're answering that. I just wrote it, h prime of 6 approximately. But if you didn't write this exactly, it's fine. Just tack on units here, and I'm sure you'd get full credit just for that. Okay, so now, using correct units, interpret the meaning of h prime of 6 in the context of the problem. Now, guys, there's a discrepancy between what we practiced in class and what I saw on their grading rubric. I think we're fine, but we'll practice a little more what they have on their grading rubric, but I'm pretty sure we're fine. What we practiced was just a more kind of specific version of this. Okay, so let me show you what we practiced in class. What we practiced in class was like this. At t equals 6 years, the height of the tree is increasing because it's positive and now this we did not practice, but this is actually very necessary. At an approximate, very important there, rate of 5 over 2 meters per year. Okay, this is not the derivative. This is an approximation for the derivative. So I am sure that if you didn't say approximate, they would not give you credit for the explanation. Okay, so this is what we practiced. Okay, on their rubric, ... Now, the thing is, guys, is that they're saying using correct units, interpret the meaning of h prime of 6. They're not asking you to interpret your estimate. So they want you to interpret h prime of 6. Like, assuming you didn't get a number that estimated it, what does h prime of 6 mean in this context? So my interpretation, I'm interpreting the approximation that I got, but it turns out that they wanted you just to interpret h prime of 6 without saying what it equals. So on their rubric, they say this. They say h prime of 6 is the rate at which the height of the tree is changing. They just say changing. They don't say increasing or decreasing because they're kind of assuming like, well, we don't know what it is, but this is what the derivative means in the context of this problem. So is the rate at which the height of the tree is changing in meters per year at t equals 6 years. Guys, we will practice both ways. All right, in the future, we'll practice both ways. Okay, so, So this is what we practiced on their rubric. They had this, though. I think we're okay. I think we're okay if we say approximate. If we didn't say approximate, I know we would not be okay here. Okay, that's A. Now, B. Explain why there must be at least one time t for t between 2 and 10, such that h prime of t equals 2. Guys, if ever they're asking you to explain why a derivative must take on some value, that needs to make you think of the mean value theorem. Okay, the mean value theorem says this. Here it is in a picture. At some c between a and b, you're going to have the tangent line slope equal to the secant line slope, okay? And how it goes is this. If f is continuous on the closed interval AB and differentiable on the open interval AB, then there exists a c between A and B for which f prime of c, the instantaneous rate of change, is equal to this, which is the average rate of change. All right, so guys, I can prove this. Well, first of all, do I know that f is continuous on 2 to 10 and differentiable on 2 to 10? Because I need that. If I don't have that, then I can't prove this. Yes, I do have that because they told me that I had this twice differentiable function, which implies both of the things that I need. Okay, so now we're going to see what the average rate of change, if the average rate of change from 2 to 10 ends up being 2, then boom, I've got it. All right, so 15 minus 1.5, that's 13.5. 10 divided by 2, that's 8. 13.5 divided by 8, that is not 2. So we are going to have to find a subinterval. This actually took me a while to find. But it turns out that the subinterval from 3 to 5. 6 minus 2 is 4. 5 minus 3 is 2. 4 over 2 is 2. Okay, so this is part B. All right, so this is part B here. All right, so let me just do the average rate of change here. So h of 6 minus h of 2 over 6 minus 2. This is 6 minus 2, nope, 5 minus 3. No. Oh my gosh, that should have been a 5. Let me just start over. Okay, so h of 5 minus h of 3, all over 5 minus 3. This is 6 minus 2 over 2, 4 over 2 equals 2. Okay, so I got that. My average rate of change is 2. And now I can jump right into it. Okay. Now I'll say since h is twice differentiable, it is continuous on 3 to 5 and differentiable on 3 to 5. And then I could say, therefore, by the mean value theorem, there exists a C for which f prime of C, shoot, it's H. Oh, I'll say T, because they want H prime of T, for which I always do that. H prime of T equals 2. Okay, and you have this up here. Okay, and then I'll be like, okay, so let me make that a T. But they wanted you to explain why there must be at least one T on this interval. So let me just say, I use the subinterval 3 to 5, and I'll say this T is also this T is also between 2 and 10. Now, guys, I brought it home with this just because I wanted to be more consistent with the way that we did things in the past. But on their rubric, they didn't go that far. Okay, they just identified the subinterval and did the whole thing on that. Okay, they didn't, but they're asking us why there must exist a T on this interval. So, you know, better safe than sorry. So I'm just answering their question very directly. Okay, yep, so there's that. So there's part B. Now, the last one is part D. All right, this one is very interesting. Okay, so the height of the tree in meters can also be modeled by the function g given by this, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Oh boy, okay. So this is part D. It never hurts to draw a picture. Okay, so we've got this, I don't know how trees go. It's not exactly a cylinder, you know. So we got this tree. I am not an artist. Okay, now X is the diameter of the base of the tree. But guys, things in nature like are not perfect. So, you know, that's not a perfect circle. So don't think about trying to use like, you know, pi r squared or anything. But we know that, and then we know that the height of the tree is g of x, just to wrap your head around it. Okay, now let me think about what we know and what we want. What do we know? What do we want? Okay, so we know the height of the tree can be modeled by that function. Okay, when the tree is 50 meters tall. Okay, so we know that g of x equals 50. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. So this part, guys, when the tree is 3 meters tall, the diameter of the base of the tree is increasing at this rate. The diameter is x, so they're telling us dx dt 0.03. Okay. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So we want g prime of t, or you could say dg dt. You could say it like that. Or actually, it's x. We want g prime of. It's x actually. G prime of x, but x is a function of t, so like that's why I put it like this. I think this is better. What is the rate of change of the height of the tree with respect to time? With respect to time means this one. Okay, now, so I was like, all right, so I'll just walk you through. Actually, no, let me just show you, guys. Is there actually no? Let me go through how I was doing it. So I know I have to take the derivative of this. I know I need the derivative of this. Now everything gets a prime after it. Everything. Okay, so g prime of x equals, the derivative of the top is 100 x prime, bring up the bottom, minus, that's the top, the derivative of the bottom is x prime. Okay, and then this is all over 1 plus x squared. And then, guys, I saw, okay, I have what I want to go in for the x primes, but I don't have anything to go in for the x's. And I actually got stuck. I was like, how do I get anything to go in for the x's? And then I saw, I know g of x is 50, but I don't have a g of x down here to plug 50 in for. Guys, telling you that g of x was 50, they wanted to help you find x at that moment. Okay, so you take 100, I'll do like a little aside. G of x equals 50, so 100x over 1 plus x equals 50. And then you get 100x equals 50 plus 50x. Then you get 50x equals 50, x equals 1, all right? That actually took me a while to see that. All right, so there's that. So I guess from the start, like, you know, if they're telling you g of x is 50, maybe you see if you could find anything else with that. So I've got g prime of x equals 100 times 0.03 times 2 minus 100 times 2. No, 100 times 1 times 0.03 all over 2 squared. Okay, and then, guys, the 0.03 times 100 is 3. So we end up getting 6 minus 3 over 4, 3/4, and then what is this? Meters per year. Alrighty, guys, that was a doozy, but super, super satisfying once you get it. All right, I'll talk to you later. Mhm.